Hello and welcome back to another episode on this channel. We will be talking about the first module in our path to becoming full stack AI web developers. We would be focusing on this section, the internet and networking section, and I'm not trying to make a long video, but hopefully the video doesn't exceed 1 hour. But we'll see as we discuss the concepts, protocols. I'm not going to talk about cybersecurity and the fundamental network architecture because I don't think we have enough room, and like I said, I don't want to make a long video, so I'll just stick to the protocols and how the internet works for now, because I think it's more important than understanding this cybersecurity and network architecture. That's for the specialists. That's not really our primary concern as web developers, full stack web developers. We want to know how the internet works because that's the foundation of all web applications. And I also just wanted to mention that I will not be following any particular order in discussing these this modules. So I might talk about databases the next time, or server-side communication, or talk about the basics of machine learning and AI, or I might make a video on how to integrate LLMs and use the OpenAI API, like I did with my idea to diagram application. And by the way, if you want to be on the waiting list for trying out my application when it's published, you can leave me a comment in the comment section. Just leave me a comment, and I can get your email, or you can message me on LinkedIn, and I would add your email to the waiting list. So yeah, I would be discussing just the modules that I find challenging to me, because I'd like to discuss them and teach them to consolidate my understanding, and also to point out a few things to someone out there who might be having similar challenges. So what I'm saying is we wouldn't be following any particular order. I will not be talking much about the front end, again, like I said, because that is really not my it's one of my big weaknesses. And also I just find that the coding tools we have now are relatively awesome, are just phenomenal at creating front ends. So creating front ends, React components and hooks, and managing component states using React state management functions that can be handled by the AI. The tricky part, the hard part here is in managing databases, building your back end, integrating AI, and making sure that the front end and the back end communicate over this RESTful APIs or GraphQL APIs. Building real-time applications, using WebSockets. So these are the parts that I would be focusing on. So I think we can get right to it and discuss the internet and what it's about, and why is it so important. Alright, the foundations of the internet and networking. The internet is just a global network that connects millions of computers, servers, devices, cameras, right? Think about a road, a network of roads and vehicles. Think of the vehicles as the messages or the packets being transferred from one point to another, and you think of the roads being the network, right? The paths. That's literally what the internet is, and it is so essential because, I mean, it's the reason why we are building web apps in the first place, right? Why you and I want to become full stack AI web developers, so that we can build these applications that can communicate over the internet, receive information, send information very conveniently. And here's the evolution of the internet. I'm not going too much into detail. With that, you can watch another YouTube video or read about the history online. That's not really the focus of this video. But just in brief, it began with ARPANET. I've done internet networking and done computer engineering for years, but I still do not know the full expansion of this, full meaning of this acronym. But yeah, whatever, man. So it began with ARPANET in the late 1960s as a project to share information among research institutions. I think it was in the US, and they had two massive computers trying to communicate, where one computer sent a login. One of them was in San Francisco, I think, and it received LO, and the GIN part of it wasn't received, and that was a kind of massive success because that was the first time two computers ever communicated or ever transferred anything, between themselves. So that was revolutionary at the time. And over the decades, it evolved from a small military and academic network into a vast public infrastructure that supports business, it supports education. We play video games, social media, Facebook, YouTube. That's really what, the bedrock of all this is the internet. What's the point of networking? We want to connect devices first and foremost. Servers can speak to each other, servers can speak to clients, computers can speak to other computers and whatever. And secondly, most importantly, we want to share resources, we want to share information. You want to be able to message your mom in Canada or the US or in Africa. You want to be in Cameroon and be able to message your people in Nigeria or France. That's really what it's about: communication, sending, exchanging data. You want to be able to receive money, even if you are not in the same physical location as the sender. You want to be able to receive cash, money, right? So PayPal, whatever. We are using the internet. So now that we have an understanding of why the internet is so important, let's look at the models, the abstraction of the layers of the internet. So literally what we're saying here is the models are just the frameworks that allow us to see how data is being transferred from one point to another. Literally, that's how it is. And the OSI is a 7-layer model, and the TCP IP model, which I think it came about in the 1990s, I think, by Tim Berners-Lee. Was it Tim? Nah, Tim was responsible for www, the World Wide Web. I think this one was, I forgot his name, but He's a prominent guy from America. He is a famous guy in the US. He came about this TCP/IP model, and so these are the two models that are popular, with the TCP/IP model, becoming the standard because it's more concise, and it allows us to just have a more concise view of the flow of information across the internet. So instead of 7, we just have 4. And so let's look at what these layers are and what they do, and the devices present at each region, the protocols present at each layer. Let's look at that. Let's look at that for a second. So we have the physical. We're going to start from the physical. We have cables and hubs. This is where encoding takes place. We have the bits, right? The zeros and ones. I wish I had a whiteboard where I could be explaining the objects. I'm just going to use my paint. So if there's anything I have to explain, I just, anything I have to write down, I could just do so here. Change this to red. Grab my pencil. Alright. So in the physical layer, we have cables and hubs where encoding takes place. We have the bits in here, so the zeros and ones, right? And again, like I said, it's responsible for the encoding. And we have the data link layer, which is responsible for framing framing the bits. Where's my yeah, it's responsible for framing the bits, right? And framing the bits, right? And here we have the Ethernet protocol. We have switches, and we have MAC addresses. The MAC address is the physical address on your network card in your laptop or your mobile device. So it's responsible. This layer is responsible for node-to-node communication. So you frame data like this and send it to the device. Now, this models they could be daunting to understand, especially if you're just a beginner, trying to understand how data flows across, each layer, from one layer to the other. So what I like to do, what I like to tell myself, to have a better understanding of this, is just think of a person and a person with a device on one end and a person with a device on another end, right? And think of the devices communicating with each other. Now, you have a person with a physical device, right? He sends a message, and let's say the person is at home, right? Local area network, right? Person is at home, and personal PAN, personal area network, sorry. So you have that person who send a message to another person here who is wherever. Could be, let's say for now, the person is outside that PAN, right? So there's two different networks. And when we talk about two different networks, we are referring to routing. We use IP addresses for two networks that are two different networks, two devices in two different networks. Now, that person sends a message. That message moves up one layer. That layer would be the data link layer. Right. Now, the data link layer will frame, as always, frame the information, send it up to the network layer. The network layer is going to do what? It's going to perform routing. Routing, which is just finding the shortest path amongst the available paths to use to send the message. And here we have like I said, routing. This corresponds to the internet layer in the TCP/IP model. And I failed to mention that the network interface, this network interface in the TCP/IP model, encompasses the data link layer and the physical layer. Right, just forgot to mention that. And so what happens now when the package is at the network layer? It moves up one layer, goes to the transport layer, and the transport layer is responsible for establishing it, like, making sure that the message goes from one device to another. So here we'll talk about ports, TCP, UDP. TCP stands for the Transmission Control Protocol. UDP stands for User Datagram Protocol. They are a bit different, but they're both very useful. TCP uses a connection. UDP does not use a connection. So when we get into programming sockets, so when we talk about WebSockets, I will explain these in more detail. But for now, I just want you to know that the transport layer is responsible for, transferring information, transferring packets from one device to another, right, by establishing a connection, or not if it's using UDP, but it's going to make sure that the data reaches that device, because regardless of whether you're using TCP or UDP, there's always going to be some error checking mechanism, right? So yeah, there's always going to be some error checking mechanism. So for example, in the transport layer we have packetization, right? So the bits, the frames from the data link layer will now be broken down into packets. These packets would be routed independently, right? They'll be routed independently, and they have to be reassembled at some point, because you want to have your the complete message, and so these packets have to be reassembled, and the transport and networking layer, they take care of that. The networking layer is going to take care of routing the packets independently. The transport layer is going to take care of transferring that data. Then your reassembled packets now move up to the session layer, which is responsible for establishing a session between two devices. So you have, after, let's say for example, if we're using a TCP connection, once the connection has been established, a session is going to be generated by the session manager. And a session can be, you can close a session, you can open a session, so that you can manage a session, right? So that's really what the session is about. A good example for this would be, when you're having a phone call, right? When you place a phone call, let's say on WhatsApp, for example, and you are using your ISP, you're using your internet provider, and you call someone in the US, or you call someone in you're in London and you call someone in the US. You've established a connection, a session, right? Now, if your ISP has has created a session for you guys. Now that session can close. That session can close if you run out of mobile internet, right? That session can be closed. So that session can be managed. That session can be so that's a good example of the session, of what happens in the session layer. And after the session layer, your data goes up, so after the session layer, your rearranged packets move up to the presentation layer. And so after that, after the session layer, you have your reassembled packets move up to the presentation layer, where the concern here is how to present the information in a way that the application, the browser on the other end, whatever it is, WhatsApp on the other end, can receive it, can interpret it. So we're talking about data formatting, right? JPEG, MPEG, GIF, right? And all this, like making sure that the extension of the thing coming in is correct, right? Because you don't want to be sending a picture and the person on the other end is receiving numbers, right? If you send a text message, you want to be sure that the person on the other end is receiving text. If you send a video, you want to be sure that the person on the other end is receiving a video. So this presentation layer is responsible for this encryption, making sure that your SSL TLS, that's a secure server layer, I think, and that encryption helps to make sure that your information is secure and cannot be cannot be stolen. And data formatting. The data formatting is to make sure that the information is received in the right format. And after that, your nicely formatted data is moved up one more layer back to the now to the application layer, where we have your browsers, your user interface, right? It's the closest layer to the user, and we talk about HTTP, FTP, DNS. DNS stands for domain name server. We're going to talk about that in brief down below. It's very important to understand as someone who wants to become a full stack web person. You're going to have to understand these. And so this is how the internet, this is how the models of the internet work. This is how they communicate with each other. It's pretty important to understand this, because like you could get a job in each of these domains, right? Like down here at the network interface level, we have trillions of jobs, millions of jobs, right? So you have people building network cards. IBM is the semiconductor company, right? Like TSMC. This is where they are, right? Building NVIDIA, right? So this is it right here, producing hardware. The internet, IP, routers. We have again hardware companies producing routers, switches, and stuff like that. We have just massive opportunities in each of these areas. That this is where we are. This is where we are. We are just working with programs that can be able to communicate, that the user can be able to use to communicate with other computers that they will never see. They can never see and will never see, most probably. So this is where we are. We are building software applications that can send and receive HTTP requests, applications that can use the FTP protocol to download files, right, remotely. And so yeah, it's good to have an understanding of this, so you can choose where you want to belong. Do you want to optimize the routing? Do you want to optimize a particular hardware that is for the internet? Do you want to optimize web applications? This is certainly the most famous, right? Everyone loves this particular one because it's just all software, right? So yeah, so that's really what we would that's really what we discussed about. We can stop here for now. When we get back, we will talk about the TCP/IP model and how packetization, why talk about the process of packetization in TCP/IP, and most importantly, we're going to talk about the HTTP request response cycle, which is really how everything, like DNS resolving, is how all requests are sent and received across the internet. So we have DNS lookup. We're going to talk about the root service, authority name service. We have to discuss. We're going to discuss rendering, in the browser. So, all right, I'll see you in the next one. Thanks for watching, and Stay tuned.